record this. Okay, our class is recording now, so we can officially start going into some information. I grabbed this, some of these presentation background slides from CDX and modified them a little bit. I just wanted to burn through some review of what we've done and then go into what we're going to be going over next. And remember that for our class guys, what I'm going to try to do is cover all the lecture information to the best of my ability like we would normally do in class. And then the plan is that we're going to meet back at a later date. Right now, they keep throwing out June, maybe end of May or early June for us to come back and have kind of a boot camp style, hands-on 100% lab time class for us to complete our hands-on activities. And like I said, we're going back and forth and figuring out how many hours that would be.
Yeah.
Okay. So with that, let's let me switch this back to the mouse and let's see if I can get into some stuff. So we've already done our engine cleaning. We detected for cracks using Magnaflux. I'm not sure. Okay, I got my 40-minute time limit is okay. I'm not sure if anybody did the fluorescent dye process in class.
I did on my head.
Did you do it on your head? Okay.
We did them in the heads.
Good.
It wasn't fun.
You know, you use that dye. It's pretty stinky, right? Like
yeah, it is.
It really
like
is
alcohol.
pretty nasty. But when you're dealing with aluminum parts, that's kind of your option. It's either that or using the pressure test bench like we have in the build area. And that thing, did any of you guys use?
No.
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 The only thing we did for pressure, well, we vacuum tested our cylinder heads. That's the pressure test
with the valves and stuff in there, right? To see if you did a good valve job.
Yeah, I got 20 pounds of vacuum.
Yeah, so the red, or not red and blue, it's like blue and yellow bench inside the build area of our shop is a pressure tester.
Yes.
We bought that probably 10 years ago. And at first it used to have a big tank in the bottom and we filled it full of water, but the water would get really nasty and stinky.
Yes.
So now we just spray stuff with soapy water.
And see if it bubbles.
And see if it bubbles. The problem is stuff always bubbles because it's so much of a pain to plug up all the holes in your cylinder head.
Yeah.
That it's almost not even worth it. So you know, I was talking with Bob Lobdill of whether or not I should buy that machine, and both him and I are kind of thinking like it's not even worth getting because it's so much of a pain in the butt to use.
Run the correct way or run the wrong way but still work. I wouldn't buy it.
Yeah. So anyways, but you guys get the concept. Like every once in a while you'll have a cylinder head that won't work with the fluorescent dye. That's an aluminum head that will work with the pressure bench. So for, one in every, 50 heads, that machine, is worth it.
It's pretty good odds.
Yeah. Okay. So I brought up this slide just to remember that if we're using the boring bar, most of our boring equipment, most of the nicer stuff, the boring machines, are going to index off the main bearing bores, so they got to be perfectly straight. And that's why one of the first steps we did is I did do that demonstration on the line honing machine, so that you guys could kind of see how that worked.
Yes, and actually I saw your son running the main cap machine.
Yeah, he was running the cap grinder. We had a disaster block in there that probably really should just be thrown out, but I was trying to save it for our engine class. And to let you guys know, where we're at, like at AR, we had a second 8 weeks engine class that was going to start that is just going to be canceled out because of this situation. So like I said, it's not just our class that's affected, man. All the classes are. Anyways, so that's why we checked the mains to make sure that they were in alignment, because before we bore it, we have to make sure that the mains are dialed in if we are going to do a boring operation. All right. This is what you wanted to do, Chris. And
Correct.
like I said, it's a pretty specialized process, and you can see that big stone humming in there. And so if you feed that stone too far into the machine, or you know, or you just don't set the machine up correctly, you can blow up that stone in your face, basically.
Right. Oh,
where it gets tricky is for the rods. The rods are offset, right? So you have to set the crank in there and offset it so that when it's spinning, the rod journal stays centered. And so if you don't get that exactly right, that's how you end up throwing pieces of stone in your face. So it's a pretty specialized process. And like I said, most machine shops that, you know, bore and hone and all the stuff we're doing, 90% of them don't do crankshaft grinding. So, and then after you grind it, depending on how much you ground, you might have to reharden areas. So like I said, it's a pretty specialized thing.
Yeah.
Bearings here, like we have talked, we went over the crankshaft polisher a little bit, and we talked a little bit about the bearings. So Chris, you said that you had to go 10 under.
Actually,
so those would be like bearings that you would want for your engine right there, because those are your oversized bearings. Meaning
it looks like I'd actually have to go to 20 because mine already had that 0.010 on the bearings.
Oh, okay. Well, what shops like Motor Warehouse will do for stuff that's common is a lot of times you'll go there and say, hey, I need to have this crankshaft ground. And they'll look at what crankshaft it is and they'll go, oh, okay, we already have another one of those ground. Here you go. And they'll give you another crankshaft that's already ground and ready to go. And they'll take your old crankshaft in. For stuff that's real common, that's something that's done a lot. And usually like stuff like, let's say it's a small block Chevrolet, they're not going to go more than 20 under, and they're going to be like, yeah, it's not worth it at that point. Just get in there.
Right. And that's where I'd have to go there because my options were 1, 10, or 20. So to rectify the damage, it needs to be ground or polished forever.
And so the bearing that's a 1 oversized, that's just there to make up for, you know, a little bit of scoring on the surface there, and you polished it out, and now maybe it's a smidge smaller because you polished it a little bit aggressively, right? All right, so we're still hitting the stuff that we've already done. I will erase some of my scribbles here.
I don't even worry about the scribbles.
Just to kind of finish this thought up though about the crank grinding. You know, once you ground the crank, you would have to go through and re-chamfer these holes. You might have to look at the chamfering on the edges. And everybody needs to before final assembly take a brush and go through, oops, that was supposed to go through there. Go through all the holes in their crankshaft and make sure that everything's clean, and shoot some solvent or carburetor cleaner or something through there and blow compressed air through there to make sure there's no metal chips in your crankshaft, because that'll of course destroy all your bearings on startup. And I've seen that happen several times where the crank wasn't properly cleaned, and within a few hundred miles the engine came back knocking because of a dirty assembly.
Right.
You know, I like to say a lot of engine building is clean and stuff, right?
Right.
So here's a more modern crankshaft polisher than what we have, and you can see it just essentially it looks like a specialty lathe with a fixture on there. And this is kind of the setup that I have at AR. We use a traditional lathe that you can lathe regular parts in, but you can then polish your crank in it.
Yeah, it looks like a stone grinder with the belt attached to it.
Yeah, it kind of does. Yeah. It kind of does, except that a real crank grinder like this can be offset so that it basically can rotate around the offset of the connecting rod. So
Okay.
all right. So we already used this machine, right? We pressed our pistons off our rods, and the big thing is that you only have to use something like this if you got semi-floating, right? So Carlos, with your Miata, you know, you might have had to use a little bit of pressure because the pin was all varnished up or a little bit of wear was there. But I want to say, Chris, you were probably one of the few students that actually had to use the piston pin press to press your parts apart, right?
Correct. Yes. I believe I can't remember his name, but the redheaded gentleman also would have had to do that as well on his Chevy 350.
Yep. We talked about the fracture rods already, but I thought this was a really good picture to show you that fractured rod, right?
Yep. They make it and crack it in half.
Yep. And then we've been doing some of this rod work. That's one of the real high-end honing machines, rod honing machines that Sun and offers. You would see places that are like a real high volume shop. You have a machine like that where it power strokes it back and forth.
Oh, so it does the work for you. Okay.
Well, yeah, it basically moves it back and forth. And one of our rod reconditioning machines at Sierra College has the power stroke feature. We had never used it before last year. I finally took the pieces out of their brand new packaging that was 30 years old and used the power stroke feature of it. But, you know, really, if you're doing a bucket of 100 rods, having power stroke makes sense. But if you're only doing, you know, eight connecting rods or something, it's not really worth it necessarily. Now, you know, I think a lot of things come down to personal preference of the shop and the machinist. For instance, at Rex Hutchinson's shop, they feel like having the machine automatically move back and forth for you and clamp the rod in its fixture keeps the rod a little straighter. So they do it for everything because they feel like they get better results using the auto feature of the
more of a straight cut.
Yeah, I have tried to measure that, and I haven't been able to, unless somebody was on there really doing a crappy job. And so, like, you see where this guy's holding his hand way up here? If you were moving the rod back and forth on the machine, grabbing it from up there, and that would set up a twisting motion, then I could see how that would give you a barrel shape to the big end of the rod. But if you're grabbing the rod down here at the base and moving it directly back and forth, like if you have good technique, I haven't measured any distortion. So it seems like I get where they're coming from, but if you have good honing technique, I haven't been able to measure a problem where you're doing it manually. So, all right. So pressing stuff back together, that's one thing that we haven't done, right? Because that's going to be one of your final assembly things.
And that's where
rather than trying to rather than trying to press stuff together and possibly damaging stuff, what most machine shops will do is we'll heat the small end of the rod and then you can press it back together by hand. And this is the same rod heater that we have at Sierra College, this electric one that works pretty well. But in this shot, you see that they got a gas one there. Now, when I'm doing stuff at home, what I will often do is I'll take a couple of propane torches and I'll set those up and hold the rod with some vice grips or something, and I'll heat it up manually and put it together. So, you know, where there's a will, there's a way. So, so you could get, you know, ingenious and put this together yourself and do it at home. I've done that.
Yeah.
But the machine like this guy right here does make it pretty darn nice.
Right. Actually, believe it or not, in my local paper, there's actually a whole bunch of machinist equipment up for sale right now.
Really?
I don't have 10 grand to lay out. Actually, I'll go grab my newspaper. I'll tell you what we have.
Okay. All right. Yeah, I'd be interested to see that.
It's even got bits and all kinds of stuff. Boring bar, cap grinder. There was a bunch of random tools, and I was like, oh, if I only had expendable income.
Yeah. Yeah. Well, we might see more of that right now with the situation we're in, but you'd have to have the income to be able to
Purchase.
to purchase it, right? So that's the sticking point.
Yeah.
Things like the cap grinders, you can't buy those anymore from Sunnen.
Oh, they don't even make them?
They don't even make them. So I bought a brand new cylinder honing machine last year and a brand new line honing machine, and it looks exactly like the one we have at Sierra College, except it's painted white instead of painted red. But I couldn't buy the cap grinders, and so I'm actually on the hunt for some older cap grinders. But anyway, so it is kind of interesting what's out there. There's probably going to be some good deals.
So yes, let's see. They've got a quick way valve seat grinding set, a Sunnen CRG 750 rod cap grinder, a Sunnen TN3 rod aligner, a pinhole with cabinet, a KO Lee tool and cutter grinder, a Quickway EBF engine block cylinder boring stand, and a Van Norman 777S boring bar that's tooled.
Wow. Yeah. Yeah, that's some pretty good stuff. It's similar to some of the stuff we have at the Sierra College shop.
Yeah.
In that what they have is the Van Norman bar is a portable boring bar, and then they have a fixture, like a special bench that they mounted on that sandwiches the block. And we have a very similar setup at Sierra College that we don't use too much, but it is nice for engine blocks that, let's say you have like a 60-degree V6, it works pretty good for something like that.
Right.
In fact, let me, we'll talk about that in just a minute. What I wanted to get into was the cylinder sleeves. I don't know if I had mentioned it, but you have, anytime you have aluminum engines, like I have this little small engine right here, right? This has a cast iron sleeve in an aluminum block, or
your valve guides.
Yeah, or you have to have fancy hyper-eutectic silicon impregnated aluminum, like you saw Porsche and Mercedes use. But most engines are going to have some type of cast iron or steel sleeve in there, right? And so with that, there's dry sleeves and there's wet sleeves, right? And the difference is dry sleeves press in the metal, and like Chris, if we were going to sleeve your cylinder, we would bore it out bigger and press in a dry sleeve. A lot of your like heavy duty diesel engines and some of your European stuff will have these wet sleeves, where the sleeve's actually made to be replaceable, and it has O-rings and stuff in here, and the sleeve can slide in and out with a considerable amount of force, but you can basically replace the sleeves. Now, if you're sleeving an engine, if you're putting in a dry sleeve, we would bore this thing out bigger, and we would make a step in the bottom here for the sleeve to rest down on.
Right. That way it couldn't go further than it needed to.
Exactly. And so we would actually bore that thing out. So we would measure the sleeve. Let's say the sleeve is 125 thousandths wall thickness, right? What we're going to do is we're going to bore the cylinder bore opening. We're going to make this bigger by 125, but we're actually going to give ourselves somewhere right around 3 thousandths of interference fit.
Really, only 3? I figured it would have been a little bit more.
Three's quite a bit. Like if you try to get more than 3, you really got to hammer this thing in here, or you have to heat the block up a lot and cool the sleeve down. And what I like to use putting the sleeve in, if I'm doing a dry sleeve, is I'll actually coat the sleeve with some brake fluid, and it helps it helps the sleeve be lubricated as you drive it in. And then like the brake fluid causes the sleeve to rust in place, and that baby's never leaving that cylinder. It's in there. And that works pretty good. If you're going to get some sleeves, and let's see if I can get out of this thing and go back to the internet here. If you're going to get some sleeves, LA Sleeve has real nice cylinder sleeve. They make real nice product. I mean, you can get sleeves from Melling, and really you can get sleeves for only like 20 or 30 bucks. But if you're building a high performance engine, like these guys will offer sleeves that actually make the block quite a bit stronger. So if you're doing something special, sometimes in that application, guys won't be sleeving an engine because it just has damage. They'll be sleeving an engine because, yeah, they're trying to make it, handle a zillion horsepower or something like that. And I was trying to get a picture of one here for you, but they got some real nice stuff. And you can see that some of these sleeves are designed where they have a lip at the top.
Right.
So you would not only make a
lip at the bottom,
a rest at the bottom, but you have to make a lip at the top. And so when it comes to using the boring bar, if you were going to put in a sleeve like one of these guys right here, that's a pretty, sophisticated machining operation, because you have 2 steps that you're machining into the block to get that sleeve to press in there. But this type of sleeve, the block's going to be stronger once that sleeve's in there than it was originally.
Right.
A lot of your more standard sleeves, like these ones over here, they'll come in different lengths, and you just machine a rest in the bottom. And so when you're using the boring bar, again, like if you're doing sleeving, you got to get that interference just right. You got to be right on your measurements. But it is something that you can do. And I would say that an advantage of the newer boring equipment that's computer controlled is you can program in the thickness of this rest, and that, like you can dial that in, and you're not manually doing that stuff. So you have a more repeatable.
It's almost like CNC at that point.
Yeah, very, very much so. Anyways, so I just wanted to tell you, like, you can go to in fact, let's do that. We got a computer up here. Let me switch it back to the mouse.
The one time you have a good computer.
Yeah. Well, my computer at home is not that good, but it's something, I guess.
I don't know. Does the old adage still count? Speed costs money.
Yeah, and welcome, by the way. You're in the garage of French Family Racing here, which is a complete disaster.
You don't even want to.
Sounds like my life.
Yeah. So, so I'm just punching up cylinder sleeves, and you can see that you can get some sleeves pretty inexpensively, and you can see that they come in different wall thicknesses.
Yeah, that looks like it's nitrated too.
Yeah, what I will say is that these guys, LA Sleeve, they spin cast their sleeves. So the machine that makes these, if I put the drawing tool back up, is spinning around and around, and so the impurities in the metal fly to the outside, and then the finished sleeve product is in the middle, and so you end up with just basically a better quality metal from that spin casting.
Right. No bad metallurgy.
Yeah. So if I put this back on the mouse, you can see like their sleeves would be basically double the price of what we saw the
on the
Summit one was, but it is a little bit better metal in there. So it kind of depends on what you're doing. If you're building something and it's just stock, that melting sleeve right there on the screen is going to be just fine. But if you're doing more high performance stuff, then LA sleeve probably be what you'd want to go with.
So hitting limiter.
Yeah, I mean, you don't think about that, but you have applications like in the import tuning scene where guys are taking Honda motors and putting big turbos and stuff on there and trying to get 800,
much
1,000
power.
horsepower out of a 4-cylinder motor. At those power levels, there's so much pressure on the cylinder walls that, yeah, sleeving becomes something that you have to do. So,
Right.
all right. So I beat you up with the sleeves. And we talked about how if you were machining for a sleeve operation, you might have to, you're going to have to put a rest at the bottom, and you might have to put a lip even at the top. And there are some limitations, like some engines, it might be so close cylinder to cylinder that you can't sleeve every single cylinder.
Right. Like
So
every
you
other.
can sleeve, like if this one had damage, you could sleeve that guy, but you can't sleeve this other guy. Or so definitely gets more complicated. Okay, so for this one, I have all boring bars fracture the surface, and I tried to talk about this.
1/2 thousandth, one
Yeah.
and a half thousandths on either side. So, right?
Yeah.
0.015.
Yeah. So what you end up with, is you want to leave 3 thousandths for
Under.
finish honing, because it's 1.5 thousandths per side. And so to do this, I'm gonna get fancy here, hopefully.
Well, it'll look just like the picture we looked at on the lab whiteboard.
Yeah, exactly. Exactly. In fact, let's see. I spent like 2 hours trying to set this up, so I'm going to see if it'll work here.
Yes, that's where I stopped at 6 and gave myself that extra 1/1000th for my finish hone.
There,
Just to be
there
on
you
the
go.
safe side.
Hey, do you guys see a little whiteboard on the screen?
Yeah.
We did.
You do, and there's my fat hand. Okay. So yeah, just like we went over with the whiteboard in the, oh, that's funny. Look at that. I could use that one. All right. But yeah, it leaves a record groove in there. And like we did in the classroom, remember that goes down about 1.5
1.5.
thousandths. So, which would be 0.0015. And the reason it goes down that far is that there's little cracks and stuff in here, and you're trying to remove all that stuff. Now, if you were honing by hand, and so these are some of the sun and hones that I use here at home for some of the small engine stuff I'm doing. Like, I don't want to be honing more than I have to if I'm honing it manually, right?
Yeah.
And so, yeah, I'm going to leave it just at 3.
Well, yeah.
But like for your case, Chris, like with that CK10 machine, like we can hone those cylinders to their final size with the honing stones.
Yes, very careful. Just time consuming. That's all.
Yeah, it just takes a little bit longer. Now I will say, if we had diamond stones, it would go a lot faster.
Yes.
And so that's the new trend in the machine world is to go to diamond honing. The downside is in diamond honing, the honing stones themselves are super expensive because this honing material is actual diamond material.
Yes.
In fact, it's so expensive that there's companies out there, like once your diamond hones wear down and you go to clean out your machine, they'll actually come in and they'll suck all the honing grit out of your machine to reclaim that diamond.
Oh, wow.
And use it again. So,
well, I'm surprised.
Some of the big machine shops, that's what happens is a company will come in every so many months and basically reclaim their diamond material that sloughs off the hone and ends up in the bottom of the machine.
Now, are they using true diamonds or are they using manufactured diamonds?
I don't know about that. I don't know if they're, they came from the cave or if they're manufactured. I would think they're manufactured. But I know regardless, they're super expensive. And part of the reason we don't use diamond stones is the CK10 can't put out enough pressure to run diamond stone heads. Number one. Number two, like the machine I bought at AR could run the diamond stones, But if somebody crashes this honing stone into the bottom of the engine block, you know, you just threw away several $1,000s.
Yeah.
Oh, it's $1,000 for one for that little.
it's expensive. So it's like it's almost not worth the risk, right? And then remember that you need different stones for different grit finishes, right? So like this one right here
is a 125 or 150.
It's a 150. What do I got right here? Oh, and okay, so this one's my 280.
Right, the 280 is the finish.
Yeah. So and you know what's going to control what grit finish you have is what do you have going on with your piston rings,
right?
What are you doing with your rings? That'll dictate like what surface finish you want from your cylinder hone. So, all right, let me switch this back to the computer and let's see, computer, mouse. Too much stuff going on here. All right. So what's interesting is the boring bar in this machine looks like an old Rottler, which is similar to what we have. This will be one of the activities that you know, some of you guys will be wanting to do when we get back in the shop. I think I've already showed you the different flex hones, and I'll tell you, like, guys, even if they have an automatic honing machine, a lot of guys will still use these flex hones,
right,
for different things. One of the reasons why you might still want to use a flex hone is because you can spin it the opposite direction with your handheld drill.
Yes.
And so that helps get breaks off some of those metal chips a little bit better.
Right, because you're always going to wind up with sharp edges, even though we can't see them on a microscope. You'd have a rough edge,
right? It's
heading in the opposite direction.
It's pretty popular now, and cylinder surface finish is getting, you know, pretty crazy these days with some of the stuff that they're doing with the low tension piston rings. In fact, if I go here and I go to this tab, remember I showed you this site before, engine. But we got our enginehones.com, and you can buy a lot of these different flex hones for what you're doing. By the way, I don't like these Lyle rigid hones. Like you can see, they're relatively inexpensive. They're about half the price of a Sun one. But you're pretty limited on what, 180, 280. I mean, you're a little bit more limited on what grits you have. You have some selections, but it's a little bit more limited. But you could get a hone like this, and you could hand hone a cylinder and add take out some distortion or something with it. And this outfit has every flex hone you could want or think of. They have them on there. And remember that there's silicone carbide, there's aluminum oxide for doing nickel sil coated cylinders, which are real popular for like motorcycles and stuff. So anyways, if you need to buy a hone, or you want to buy yourself a dial bore gauge, I remember this website has some pretty good deals on that stuff. Okay. So we talked a little bit about crosshatch stuff, and what I will be posting on our Canvas website this week is a video of old Butch Riley doing honing at his shop there.
Oh, that's what the discussion was about. Okay.
Yeah. So I posted a video with boring, and I apologize. I was really struggling to get it loaded, and the video's like like an hour and a half long. What I will do is I'll try to break the videos up into maybe smaller segments. I just got to get my video editing software. I got to get Camtasia working correctly. So I'll try to break it up. But he does a good job going over it. I wanted to show you this picture of the torque plate. This is what Brian and I were trying to use, and we ended up probably causing ourselves more harm than good, because we had a head bolt, or not the bolt, but the threads in the block strip out. But basically what a torque plate is it simulates
the cylinder head.
Yeah, it simulates the cylinder head, right? And it's amazing that the head does distort. I mean, the block does distort a little bit when you put this torque, when you bolt the head on. And so you either have to make one of these or buy one for each engine that you're going to use it on. And so it's kind of a high-end type of deal, right? Like if you're building race motors, this becomes an important thing.
Yeah.
But you know, most stuff we don't worry about a torque plate. Now, if we were, you know, building NASCAR engines,
it would be a requirement.
Then we would not only have a torque plate, but what they'll do is they'll hook their block up to coolant, and they'll have hot coolant circulating through the block as they hone it with a torque plate on and diamond stones to try to perfectly simulate how it's going to run in the car.
Right.
So anyways, but most performance shops that are, you know, more normal, like if you went to Rex Hutchinson's shop, again, they would put it in. It was a popular engine that they had a torque plate for. They would put a torque plate on for that operation. It is kind of a pain in the butt when you put the torque plate on, right? Because you have to have a head gasket on here. You got to torque it all down. You got to take it out. It kind of throws you off as far as getting your dial bore gauge and doing your measurements. I mean, it definitely adds some complexity to the honing operation. And so you would pay more for an engine to be honed and prepped and set up with the torque plate than without. And what I haven't had the opportunity to do, which is on one of my bucket list goals, is to, you know, basically build a couple identical motors and torque plate one and hone it to final size with the torque plate versus one that I didn't do that, and see if I could actually measure the power difference or not.
Now,
If there's actually a difference.
Yeah, if there's, I mean, I
So
assume
now
that
would
there's
this
gotta
be? At this
if-
point, you would be getting into blueprinting, wouldn't you?
yeah, I mean, so if you're doing something like this, you're actually using a torque plate. It is more of a blueprinting operation.
Now my question is, could you just use heated oil on your block to get it closer to temperature while rather than trying to run it through the hole? Because like the oil being dumped out by the machine, if that was closer to the 125.
Yeah, that's a good point, man. Possibly. One thing you'll see, the diamond hone, the machines that are running diamond hones, they won't run a honing oil. They'll usually use a honing coolant.
Okay.
So yeah, maybe that could be heated. It's a little bit outside of my area of the type of honing I've done.
Right.
But yeah, that
wondering, because if you got the whole block up to, we'll say 125, because it's constantly having that heat temperature dropped on it, wouldn't that be closer to normal, 200 operating temperature, 180 to 195?
Yeah, the machine that I've seen, and I've only seen one machine that actually had the ability to do it. It reminded me of our cylinder head pressure tester, where it had a bunch of plugs you put in it, and it was pumping coolant through the water jacket passages. So, yeah, kind of interesting stuff. All right, so just to wrap stuff up. First of all, I wanted to say that I appreciate you guys being out there, and I'm really happy that that you guys are safe and you're healthy. And
so far, my wife.
It's good. It's good to see some faces and hear your voices, because this is a little bit of a weird. This is a little bit of a weird deal.
It's very unorthodox.
Yeah, it just, so it's been nice to connect with you guys. I wanted to just wrap stuff up, a few things on Canvas, and I was going to show you some stuff well, I'll show you one thing in the book, and I'll give you one tech tip. But let me see if I can get Canvas going here again real quick. And I made the mistake of closing it out, so it'll take me just a second, because it's got to send my phone something.
Yep.
Hey, there it goes. Okay. 753. Okay. So while I'm opening this up, have all your Sierra College teachers got something up on Canvas for you now, or?
Yeah.
Okay, I'll be honest with you, I was struggling. I never really intended to put our class on Canvas because my focus was on the hands-on stuff. And
Right.
what do you know? Like, so it's been a little bit of a struggle. So, you know, each week I'll try to have announcements here for you of what we're doing.
Okay.
For the assignment here, I have a couple different assignments up. The first one, just like, I wanted to make sure everybody was okay, and then I'm trying to kind of get a head count for who would be interested in coming back to the shop and finishing up, so I can relay that to the administration. Now, I'm not trying to chase you guys away or anything. I did want you to know that the school is working on a way for you guys to drop, and you wouldn't receive negative marks on your transcripts.
Well, would they be issued a refund with that as well?
Yeah,
I believe there is. Yeah.
I did have a call with I believe it was admissions or a different department.
Good, because they were supposed to do that. Again,
Yeah.
on this front, Sierra College is ahead of American River College, because they haven't made that announcement yet. But I believe Sierra College has it. You could drop the course, get a refund, and it wouldn't even leave a W on your transcripts. At least that's what I've been told.
Okay, so now my question, Mr. French, for you.
Yeah.
How close of a course does ARC have to this when it finally does open again? Would it be worth me dropping it now and just re-enrolling in your school, doing what I'm doing?
I was going to have the same question too.
Okay, that's a good question. So it will be super similar. Okay. What I did though is I took our basic engine class, where the students take apart and basically do an overhaul on a small block Chevrolet. I took that class, and in that class the students don't get to do their own engine build. So the class I've written basically is like you took the A class and the B class and combined them into one course.
Right.
So we'll be doing the same major machining operations. We won't really be talking about how an engine works or because all that stuff is covered in the A class.
Right.
The major operations that we're doing in this class: boring an engine, honing, resurfacing, and balancing. I'll go over those same things, and I'm going to throw in a couple of blueprinting type things, like how to degree a camshaft, and if you want to CC your heads. What I don't think students will be able to do is, I don't think they're going to have enough time to do everything. So,
well, in my situation, I'm honed to 9,000ths. I'm a thousandth away from where I want to be on 5 out of my 6 cylinders. That's where I only have a little bit of work left to do there, and then it's back to all the other machines.
I don't know. How I look at it is that, I'm going to try to make what we do online relatively painless. I basically took what the final I was going to give you for the class, and I'm going to just chunk it into a few sections and give it to you online. And I'll cover some lecture info with you. and at least you get you may get access to the machine shop again if you stay in the class here, because
Well,
even if you complete this class, it doesn't mean that you couldn't also sign up for the ARC class.
right.
The only reason I would drop this class is if you're like, you have so much going on in your personal life that you don't want to deal with it right now, then I would say drop this class and we'll see you at AR when I get that going.
Okay.
But I would be inclined to just stay in here. I'm not going to give you a million term papers and a bunch of crazy stuff to do.
Right.
If you can watch some of the videos that I post or participate in a webinar now and then, and like I said, the final I was going to give you guys anyways at the end of the semester, I'm just going to take that and chunk it up and give it to you online. So,
well, I know we
difficulty, it really shouldn't be any more difficult than it was, right? Because I've done online classes personally, and I've always been like, wow, this online's way more work. So I'll try really hard to not make it more work, and at least then you might get the opportunity to get some more work done in that machine shop when it opens back up. Would be my feeling. Okay, so
I did want to ask. I did respond to you here on this. I don't know how that works. I'm not 100% sure.
Okay. So if you email me through Canvas, it comes to my little inbox right here.
Right.
So you can see
if I can find mine and see, because I did try and respond to you, at least for the
discussion thing,
the wellness and future plans. I'm just not sure
what it probably did is it went to my, so you might have sent it to my Sierra College email. Like if you went, I don't know if you
I had to do it all via phone. I just got my computer up and running and able to use it.
Okay.
So I don't know quite how I'll just resend.
Okay, yeah, because so if I go to my inbox, I got a message here from a couple messages from Brian.
Right, and that's the one from me.
Yeah, and then I got this message from you, Chris, but that's all I have so far. Now I might have stuff in my Sierra College email. I have to totally log out of stuff to get. I have to log out of stuff to get into that email though. So I'll check it. But if you email me through Canvas, it should come to that little inbox. The other thing you could do is there's this discussions tab, and
right, and that's where I think I had replied.
Let's see. Well, then it should.
Yeah, I only saw Phillips.
Yeah, here's Phillips.
Right,
I'll put up a discussion just for general stuff too.
Right.
I can do that. So, and then we'll have basically a few quizzes. And like I said, I'm just taking the final that you normally do, and I'm chunking it into sections.
Okay.
And so you can do it multiple times, right? You can do it 3 times. I wouldn't do it yet because we haven't covered all the stuff yet. But basically I have 16, basically I had a test that had like, I don't know, 50 questions on it. Some were on the engine block, some was on balancing, some was on pistons, and I'm gonna take that and split it up. So anyways, I better wrap this up. Let me give you guys one last tip before we break. And that is in our current situation, if I can get the document camera going, you might be building engines and stuff at home, and maybe you're at home and you want to figure out, well, do I need to send this engine out to the machine shop? Maybe you don't have micrometers and stuff. One thing that you can do is inspect your cylinder bores with a piston ring. So let's see if I can get this guy to work here.
I can see a single cylinder.
You can see so in the French Family Racing Shop, you guys know we did a lot of go-kart engines, and Carlos, you were at the track.
Yes, sir.
Before those 206 engines became super popular, we ran these clone engines, And the thing about the clones is you could build your engine. In fact, there was a whole rule set, and it was constantly a race of, like, they were constantly coming out with new parts, like billet aluminum light and
Oh,
flywheels
wow.
and different performance camshafts. And so when we were racing clones, man, I was building these little engines right and left. And on one hand, it was a lot of fun. On the other hand, man, it was also a lot of work. So I have a bunch of the small engine stuff laying around here.
So is that still Brazen Stratton, or is it made?
No, this is, so you know what this is? This is a Honda clone. So this
Okay.
this engine, let me see the front plate. Yeah, this has the flat front. So this engine here was actually from Harbor Freight Tools.
Oh, okay.
That you used to be able to use a coupon and you could get it for like $130. And you could buy this engine. But then if you were going to be competitive, you had to go all the way through it. So you can see I have my marks on here.
Yeah.
This was French Family Racing Engine number 4. And, you know, like if it got to the point where if you didn't have everything blueprinted and dialed into the nth degree, you weren't going to be
Running.
yeah, well, you weren't going to get out of being mid-pack. And towards the end there, it's like you weren't going to get out of the back of the pack.
Yeah.
Now I'm looking for, oh, there it is. I'm looking for my piston ring. Oh, so one of the things I did for the side case is I studded it, and
Yeah, I can see that.
yeah, anyway, so it was crazy amount of work in these little engines.
For how small it is, too.
Yeah, but you know, I mean, you can do it at home, and it was pretty, in a lot of cases, it was pretty fun. So here's what I'm doing is I'm putting a piston ring in there, and I'm squaring it up with the piston, and I'm trying to press it down in the bore where we would have the most amount of wear. And then I'm going to shine a light in here if I can. And of course I couldn't find a flashlight, so I'm using the light off my impact gun. But the idea would be is if you put a new piston ring in the cylinder bore and you shined a light in there, if you could see light coming from around the edges of the piston ring, that would tell you, hey, that engine
The
needs to
clearances
be,
are too loose.
yeah, it needs to be bored or at least honed with a rigid hone.
Mm-hmm.
And the reason is, if I wipe this down, you know, we've been talking about taper,
Yeah.
right? Bigger at the top than it is
Smaller
at the bottom. But what's more critical than that really is the out around. So if I have a perfectly round cylinder bore, my piston rings are perfectly round, right? And everything's good.
Mm-hmm.
But if that cylinder bore is oval shaped, right?
Yeah.
If it's out around, well, I don't care if I got new piston rings in there, they're not going to seal at all. So an easy way to see if you have out around is just to throw a good piston ring in the bore. And if it is out around, you would get light shining through on the sides, and that would make it real obvious, like, oh, this sucker's out around. I'm
Mm-hmm.
either going to have to bore it out, or I'm at the very least going to have to hone it out with a rigid hone to get it back within standard. Because piston rings, hey, they can expand and contract, right?
Yeah.
And so they can handle a little bit of taper and grow and shrink, but they really can't handle out around. And so that's why where you might look at a specification and I might say, hey, I can handle up to 3 thousandths of taper,
over.
but I can only handle maybe 1 thousandths of out around.
Oh, okay.
Usually your out around spec is a tighter specification than taper because the piston ring's round, man. It can't handle an oval. That oval's not going to work. So that's a good way if you're building engines at home or you've ripped apart an engine and you want to see, well, could I get by with just flex honing this dude? Or does it need to be taken to the machine shop or honed out with a rigid hone or bored and honed or whatever?
Yeah.
That would be an easy way to see what you got there. And that would apply to a small engine, a car engine, a motorcycle engine, whatever you're working on. So So that's my little tech tip for you guys if you're doing stuff at home. And there's quite a bit of the disassembly and assembly stuff. There's quite a bit of stuff that you could do at home, really. So
Yes. And then I actually have another note right now on Motor Trend for anybody who's got that channel. There is a show, Engine Masters is back on for season 5.
it is. Yeah, I do really like that show.
Yeah.
I think it's on Amazon Prime too, I believe, or
Yeah,
Roadkill is.
Right.
I know Roadkill is. I don't know if Engine Masters is.
Yeah, I don't think Engine Masters is.
I will
the
check it
premiere
out.
was testing rod ratio effects, the difference between a shorter rod and a longer rod in exactly the same engine.
Yeah.
So
Yeah, that's great. Yeah, that is a
something to
great
look into
show.
if you've got some extra time at home.
Yeah.
Personally.
I mean, we
Which
all have
I think
plenty.
a lot of us do now. So,
So send it to record.
all right, gentlemen, we actually went longer than I thought. I
That's
appreciate you hanging out. Thank you for being here. I'm gonna wrap this thing up. Next week we'll try to do this again. We'll talk more about honing. I'll get out our book and see if we missed anything. And you know, my goal will be to get us through all the lecture information, and then we'll kind of wrap stuff up. And our goal is to get us back in the shop as soon as we can get back in there. I'll also piece together the hours with you and hopefully have some news next week of how many hours of shop time we could possibly get when we can get back in the shop. Okay. You guys take care of yourselves. Stay safe, stay healthy. Hopefully you'll be able to get some work too. And
Hoping so.
yeah, you know,
I've been trying.
Getting laid off again.
yeah, no, I feel it too. My wife was laid off from one of her jobs. And,
Oh man, I'm sorry.
Yeah, I mean, it wasn't like the main bread income, but like we're all kind of in this boat together. So hopefully, hopefully this thing won't get that
We'll
much
make
worse.
it through. It's just gonna take some time.
Yeah.
Exactly. All right, guys. Well, thank you so much for being here. Send me some emails through Canvas if you have questions on anything, and we'll try to catch up next week. Okay.
Of course.
Okay. All right.
Have a great weekend, Mr. French.
Good night, everybody.
All right. Good night.
Good night, Phil.
Good night, Chris.
Brian.
Good night, Phil.
Night.
Bryant.
Night, guys.
See
Thank
ya.
you.